This equation looks impossible to solve, but let's solve it together. Now we have 2 raised to power x plus x is equal to 5. How do we solve this? Now the first thing to do here is that we can say 2 raised to power x is equal to 5 minus x. Moving on, we can divide both sides by 2 raised to power x. So we have that 1 is equal to 5 minus x over 2 raised to power x. Now, moving on, remember that if you have a raised to power m, okay, 1 over a raised to power m can be written as a raised to power negative m. Okay, so applying this rule here, we would have 1 to be equal to 5 minus x multiplied by 2 raised to power negative x. Okay, now moving on, we have that 1 is equal to 5 minus x multiplied by 2 raised to power negative x. Let's now multiply both sides by 2 raised to power 5. So multiply this side by 2 raised to power 5. Multiply this side by 2 raised to power 5. 2 raised to power 5 is equal to 32 times 1, which is 32, to be equal to, on this side, we have 5 minus x multiplied by, now since the bases are the same, you can add the power. So we have 2 raised to power 5 minus x. Okay. Now, recall that the Lambert's W formula, okay, states that if we have W of x e to the power of x, it is equal to x. So we need to express this in the form where e is. So it means that we need to replace these 2 with e. Okay, so we are going to find a way to put e here in replacement of 2. Now let me show you guys something. If we have 2, okay, and let's say we take the natural log of 2. So natural log of 2 will be log in base e of 2, which is equal to ln of 2. Okay, now let's say that this natural log of 2 is equal to y. It invariably means that e raised to power y is equal to 2. Alright, now if e raised to power y is equal to 2, what was our y? Our y is this, or this, ln of 2. So it invariably means that if you have that e raised to power y now is ln of 2 is equal to 2. Does that make sense? Now we're going to apply these laws here. Okay, so we're going to replace 2 with e raised to power ln of 2. That's for this. Okay, let's do that quickly now. So plugging in e raised to power ln of 2 in replacement of 2, we have 32 to be equal to 5 minus x multiplying e raised to power ln of 2 into 5 minus x. Alright, now recall we need an expression in the form x e to the power of x. Okay, we need something in this form. Now, how do we get this? Now you've seen that we have 5 raised to power 5 minus x and 5 minus x. We have ln of 2, but we don't have ln of 2. So let's multiply both sides by ln of 2. So we have 32 times ln of 2 to be equal to 5 minus x times ln of 2 multiplied by e to the power of ln of 2 times 5 minus x. Okay, now you can see that we have the same thing on both sides. So from here we can now say that w of 32 multiplied by ln of 2 is equal to, now as I've told you initially, w of x e to the power of x is equal to x. So w of this e to the power of this is this. So we're going to have ln of 2 multiplied by 5 minus x. Okay, now dividing both sides by ln of 2, we now have that 5 minus x will be equal to w of 32 ln of 2 over ln of 2 is equal to 5x, or 5 minus x rather. Hence, x now become equal to 5 minus w of 32 multiplied by ln of 2 all over ln of 2. Okay, so this now becomes the final answer to this question. Sorry I didn't get the actual value, but if you go to Wolfram Alpha calculator and search it on Google, you will get the answer for this. Thanks for watching.